Yeah, we're going to talk a little bit, and I'm going to try to stay in my lane as best as possible. And we'll put the first slide or two up there. Okay, let's go to the next one. I'm a behavioral scientist. So like I said, I'm going to try to stay in that lane as much as possible. But we've now been playing with various technologies over the years. And now one of those newer technologies, we're moving into the AI space. And you know, it may be helpful in some way to talk a little bit about how humans interact with this thing, because ultimately it's going to be humans who do this stuff, right? And so in the red there, these are some studies. We published work in all these kind of areas, and that basic behavioral science has led us to do a number of studies, which I'll talk about in a second, using things like thermographic stuff to try to measure things like deception, and lasers to measure things. And we own a patent on some software that reads facial expressions. Apple bought that, so we kind of lost that now. And done a number of things, as Brian was said, dealing with a lot of people, including there's a TV series out there you can get on YouTube called Inside the Mind of a Con Artist, where I'm one of the experts, not one of the con artists. Let's get that straight. Where we analyze the behavior, like what makes them. That includes people with financial fraud, guys like Helmut Keener, who's referred to as a mini Madoff. You know, and what makes them tick? How are they able to do what they're able to do? But again, studying, and then of course consulting on a number of cases and training pretty much every U.S. federal agency along the way. So, but it all stems from understanding human beings. Right? And I think one of the things that made our software on the facial expression work so well is that the computer scientists work with me, a behavioral scientist who's been studying faces for 20 years. Because there's a lot of programs out there that will read faces in real time, but they're not correct. So for example, if you smile, use this muscle called zygomaticus major, but that actually doesn't predict whether you're happy or not. You actually need the muscles around the eyes as well, called orbicularis oculi. But yet these systems will call it happy just by doing this. And we smile for all sorts of reasons, including to hide a lot of other things. So Abdul, let's go to the next slide. To give you an example of how this stuff works, yeah, these are my primitive PowerPoint skills. When it comes to reading people, you know, I've always said, you know, well, there's an art to it, there's an art to it. And I've always said art is just a science we haven't figured out yet. And the AI may help us get there, but in a sort of an interesting way. And we've often talked about AI as well as a solution in search of a problem, right? On a lot of things. But let me take you back 30 plus years when we published this paper looking at those differences in smiles. And again, there's a little diagram here showing some of the neuroanatomy of the face. And like I said, when we're really happy, we show both sets of muscles. But also it turns out that the flow pattern of this muscle also discriminates if you're really happy versus faked happy. The problem was in 1993, in order to measure the flow pattern of that, they had to basically figure out when did the smile start to move, and then when does it hit its apex, and then when does the apex come off, and when does it end. And we found that when you're actually happy, the length of all of those durations correlate together, and they correlate with the overall length. When you're smiling, be polite, the parts don't correlate. Now, that took me 6 months to code 44 subjects, plus bribing someone else to be a reliability coder, right? So, that was the technology back then. Now, let's go to the next slide. Since then, we've done a number of things looking at it, and I'm going to just jump over to the middle one, is auto-expression reading. It turns out, as we were developing the software to read the facial expressions in real time, my computer science colleagues, as we started to develop, said, oh, look, here, we're measuring this particular muscle movement, we're measuring this one, and they were producing these onset curves. Now we're looking about 2010, right? So this is the auto-expression reading. And one of the things, the CERT system, that's computer expression recognition tool. And I said, do you guys know what that means? And they said, no, it just tells us that the thing's moving. I said, no, did you know it took me 6 months to code 44 subjects and you're producing this automatically and you have no idea what it means in terms of the significance of the emotion, right? And to give an example of that significance, so in this paper here, we actually had people in real pain and fake pain. So real pain, stick your arm in a bucket of ice water, okay? Real pain. Called the cold pressor test. Or put your arm in a bucket of lukewarm water, but pretend you're in pain. All right? And we took videos of this, And we applied the computer vision system that read the flow of these movements and things, as well as the presence or absence of the movements. And we had the system try to determine which is which. And we had human beings look at both videos. The same person, right? So here they are, real pain, fake pain. Can they tell the difference? Well, the humans were getting about 55% correct in identifying real pain from fake pain. But the software got 85% correct. And the key discriminator was not which muscles moved. It was the flow of the movement. So now, and this is now, of course, being built into these AI things, it's discovering and being able to analyze patterns that to the average person is a little invisible or really awkward to be able to discover and to be able to measure in the process of what we're doing, right? So again, it was the same muscles, just the flow was the difference, and that separated the real from the fake pain. There's other sorts of invisible things. Talk about the art is just science we haven't figured out. Well, one of these things that technology is doing is making apparent these things, not only the flow, but even things like the heat patterns on your face. The top one is a thermographic unit. It turns out the little red dots in the corner of your eyes, the change in the heat pattern there actually predicts deception. And in our paper, humans looking at these videos can only get 59% correct. But measuring the heat patterns in the inner corners of your eyes was 82% correct. Now, it's an infrared signal, so if you wear glasses, it doesn't work. We tried it in the airports, and it didn't work because there's just too much behavioral noise. People dragging bags, stressed to miss their flights. Even if you chew gum, it produces too much noise. And I know that a little bit because I was asked to be the chief behavioral science officer for TSA. And so we worked a lot on, airport security things and stuff. I turned it down because it just, had to move to Washington. Kids were young. And, 180,000 a year would do really well in Buffalo, but not so well in D.C., right? So the wife kind of put the kibosh. So anyway, long story. But point here is, so we understand how these things try to work in the applied environment. And that also means how humans interact with technology. And there's some lessons learned from that, which I'll talk about in a second. But the government's goal at some point is for you to walk into an airport, have your ID, and you just walk through, and at the end there's two doors. One door opens, you get on the plane, the other door opens, and there are people who pat you down and hand search your bag. Okay, without interacting with anybody. So they're always looking for these remote technologies, and we worked on some of them. So the infrared is one of those things, the facial movement's another. And then we worked on this one, which is interesting, it's a laser. And we had people rest their face and then think of a bad smell. Because when you feel the emotion of disgust, your upper lip pulls up. It's the levator muscle, right? And we put an electromyographic sensor on it, and we also used the laser, right? So we told people, just rest or think of a bad smell, but don't move. And then tense your muscle, but do it in a way where no one can see it. And then just barely show it, and then, show it, and then give it your maximum thing. And we compared this laser, which was developed by the Boeing company, to measure tolerance of airplane parts. Because some of these things are so precise, you handle it, you change it, right? So you need something to measure it without getting your hands on it. And it measures little tiny micro vibrations in the face. So the little light you see here, it's a visible spectrum laser. And it turns out that when you're looking at the pattern, EMG, which is the thing actually connected to your face, kind of doesn't get much here, and then only when you kind of get to the maximum does it start to pick it up, or when you get to this readily visible tension and barely visible tension. But look how much better the laser picks that stuff up. Right? So, again, this idea of the sort of visible and the technology helping to reveal to us these things that we ordinarily may not be able to see. All right? And so this technology becomes important later. Abdul, let's go to the next one. Also, looking at this, and this was funded by the Department of Defense, looking at predictors of genocide and violence. And it turns out there's three emotions when they're packed together actually predict it. And so we went through history and looked at speeches of Hitler and before the Rwandan genocide and so on. And it turns out there is a predictable pattern. And you compare it to things that did not turn violent, like Gandhi's Salt March or Martin Luther King's March on Washington. It turns out in both instances, as you get closer to the event, the reference to the out group, the amount of anger goes up. So they're the same that way. But the difference between genocidal or homicidal events and non-homicidal is the reference to the out-group. They start using contempt and disgust, seeing those people as beneath you, seeing those people as offensive, right? Because if you see a cockroach, what do? Step on it. What if it's a baby cockroach? Step on it. What if it's a cute grandma cockroach? It doesn't matter, right? And if you're wondering, like, well, how can some terrorist group blow up a bus full of children? Here's how. If you think of them as baby cockroaches or whatever, right? So this became really important, and part of the reason the government uses it, and it's now used in this thing called sentiment analysis, because, you know, we listen to the world. And the world's a big place, and there's only so many humans who can analyze this stuff. And one of the big problems you have is what that does produces mountains of data, giant haystacks of data, and you're looking for the needles. And one way is to try to detect the needle. That's kind of difficult, but you can actually help the process by simply knowing which part of the haystack or eliminating a lot of the haystack. And it's used, you know, when people use some of these, we'll talk about later, the AI systems, a lot of it is, in fact, the productive way enables you to actually eliminate a lot of stuff. For example, people looking at depositions, you know, 10,000 pages of a deposition, if you can get it down to 100 pages where all the interesting stuff is, that's very helpful. Even though you're not necessarily detecting it, but it's actually helping the task in that way. And so this is what the government's doing. It's monitoring the world, and it's looking, for example, it's not classified anymore, any of this stuff, but like if you get Twitter traffic somewhere, you know something's happening. So let's get a human, what's going on? Let's start looking at our sources. And this is also going beyond not just simply something happening, but we may have some violence afoot between certain groups, right? And more recently, we're now looking at an individual level. So one of my students had done this particular study, looking at, for example, diaries of school shooters and things like this. Can you predict the violence from this? And one of the things we want to do is to automate this stuff and use the AI systems to be able to do this at the individual level, because we know on the global level it's going to be used in that particular domain. So again, throwing out where this stuff might go as we see where and how AI stuff gets funded. Abdul, let's go to the next one. But you can't forget about the person in the process. And it turns out that the relationship of the person to the other person often affects how well these systems are going to work, right? And in particular, this idea of rapport. One of the things that we find in rapport is that even in the deception domain, the extent to which the interviewer is building rapport, detective with a suspect, whatever, it turns out you get better signals. People are more willing to disclose things to you. And this works in the medical field, and this works with street gangs, and this works with terrorists, right? Now, rapport consists of similarity, empathy, and liking. And when people are in rapport, they do things. They mirror each other's behaviors. Their behaviors actually start to synchronize. You get a nice conversational flow, and so on and so forth. And of course, when you think of it, not only do you get the stuff, as you see, the more diagnostic stuff, but we've now seen, of course, AI systems are able to show empathy, right? There's a lot of people now have their AI friends, right? Because AI is able to replicate some of these rapport elements and the liking. So when you think of similarity, empathy, and liking, which are the three legs of the stool, of the rapport stool, if you will, the similarity part is the one we're not so sure about. Like, to what extent do you feel similar to this AI chatbot or whatever it is that you're using? And this is a little bit more unknown to the extent to which people can actually do this or not. And this is where there'll be some additional work on it. But certainly, the empathy and the liking part, that's already done. That's here, right? So again, how much rapport can you build with this? Well, we're not so sure on that, though. Abdul, let's go to the next one. And just to show you, this was Ali Soufan. He was the guy who interviewed the courier who gave up the location of Osama bin Laden. And he just talks about just how important rapport was. He was a rapport builder. Right? TV always makes you think the best interviewers are the tough guys. You know, listen, punk, you know, and throw them. It's great television. It's horrible interviewing. And this is the best way to get stuff. So the human in the process matters. And we even know in our deception research, if our interviewer doesn't have rapport with that person, when they're lying, telling the truth, there isn't much of a difference in the behaviors. But if they're able to establish the relationship, then all of a sudden some of the emotional stuff does discriminate the liar from the truth teller. So it is a necessary step. And this is now going to be important when we talk about AI in just a second. Abdul, let's go to the next one. All right. So this is the stuff we're working on now. As Brian had mentioned, 5 years, $20 million from the National Science Foundation. We're a year or two in. And part of what we're trying to do is look at something where a very underdiagnosed situation in the United States, which is children with learning disabilities. And there's not enough speech-language pathologists out there to do this. So developing automated systems to screen for it so that those children can get the stuff. And this is our institute, by the way. We have our own little logo and everything. That's what $20 million does, right? You get your own logos, got a pin. You see my bag, you know. It's really nice. And even a shirt. So anyway, and with my colleague, Ifeoma Nwogu over here. And so she's a computer scientist and I'm a behavioral scientist. And then the other part is not just simply to screen and identify, but to create an orchestrator that interacts with these children. And what this means is this orchestrator has to be able to read and to some extent understand these children and provide communication back to the child to give them some bits of information. So one of the things we know from the previous stuff is these systems are getting pretty good at recognizing various emotional states. But in the learning space, you also have these cognitive states that you like confusion and things like this, concentration. But also, the most important thing we find out with these kids is this rapport, or sometimes they'll use the word engagement. Because if the child's not engaged, it doesn't really matter so much. Now, we've been able to actually use these systems, AI systems, to identify when people are in rapport or not. And there's a little scene from one of the papers we did. And one of the interesting markers is if somebody shows you one of those smiles with the eyes and the lips, and if the other person shows that back to you before that smile leaves your face, that is one of the better markers that people are in rapport. And then their body's synchronized. So if you lean over a little bit, then they kind of lean over a little bit. And you know, so you see all that kind of coordination. But anyways, trying to identify this. So we're trying to nail at this point things like confusion, which the movement characteristics of that face hasn't really been fully identified. But we realize it's a two-step process. Abdul, go next one. So it turns out that you have to be able to identify these relational elements, the rapport or the engagement first, before the stuff you see with the child, either emotional or cognitive clues, actually matter. Now, we've got the face broken down to this facial action coding system that my colleague Paul Ekman had created, where you can take the face and every one of its visible movement characteristics, and so we can articulate what those things are. But it turns out in terms of the usefulness, in terms of understanding what the child is and being able to interact with the child, either through an avatar on a screen or ultimately something like a robot, turns out it's going to be important. And I'll mention this a little bit later, but sometimes these kids with the learning disabilities, and particularly if they're on the autism spectrum, they often prefer interacting with the robots than with people. All right, so this may be some way in to get them, but making sure that they are engaged, then all of a sudden these behaviors become useful to you in terms of understanding. Are they processing? Are they understanding the stuff? And now does the avatar or whatever, does they need to adjust what they're doing in relation to how the child is reacting to those sorts of information? Look at the next slide. Now, one of the problems you have with AI stuff, it's only as good as the stuff that goes into it. And if AI is scraping the internet is full of nonsense. So your AI systems are like the guy at the corner of the bar, you know, Cliff on Cheers, you know, just kind of, right? The internet, you know, AI sometimes knows stuff that just doesn't exist. All right, but I used to work in a bar. I used to be a bouncer back in the day. And yeah, there are a lot of people with a lot of very strange opinions out there. And AI will do the same thing. In fact, I beat AI watching a Sabres game. They had a little quiz, like they give the question in the first period, they give you the answer to the third. And I got it right, and AI got it wrong. Right? It was like, 4 years in a row, 100 points. Oh, Bobby Orr and Wayne Gretzky. And they only got Gretzky. So anyway. But the problem is, when you look at these AI systems to read these expressions, they're based on various databases. But if you look at those databases, you realize they're normed on almost nothing. But the research literature says these are well-established databases, and they're not. It's the problem. They all have some major problems, and particularly if you're trying to create an AI system that's going to read the behaviors of these children, you need stuff to norm it on, to train these systems on. And unfortunately, there's a lot of stuff that's just not as helpful as we would think, although the literature will say that it is. Abdul, go to the next one. And so, again, this is kind of small we have in here. But one of the solutions might be to actually create some of your norm stuff, but this now becomes problematic. So these faces here, these are AI generated. And the one over here, the kid in the purple, this is an actual kid, right, on this. And trying to get samples of children to pose this, to train these expressions on, because children's faces pretty similar to adults, but a little bit different, is very hard to do this. So we're actually doing the experiment now. The problem with some of the previous studies that tried to do this is, again, the instructions that were given to the AI system to generate the face was not neuroanatomically correct. So the behavioral scientist, me, have gone in and say, well, let's make it neuroanatomically correct and so I have a student doing that literally as we speak now. She's doing this as part of her master's thesis, is trying to change those prompts in the AI to try to generate something that is more realistic and natural in terms of what we actually see with actual faces, with actual human beings, and then see if you can train systems on that. So the study is she's going to train it on the old stuff generated and then the stuff with the more neuroanatomically correct, and then see the extent the AI systems can read real emotions and real cognitive states in kids in real time. And again, this would be huge to be able to create this sort of stuff. So again, AI can work in this space, help you get to the materials that help you make your AI stuff better along the way. And again, keeping in mind with human beings, we may be dealing with these compound behaviors. You maybe have to measure whether they're engaged or in rapport first, and then the emotion stuff becomes more relevant. So there may be a two-part judgment that goes on in here. I'll do on this. Now, the slides have come up kind of interesting, not quite, but nonetheless, we can work with this. On the dark side of AI, some example with dealing with us and humans, is AI, when it comes to detecting deception from written statements, does no better than people. But it makes the same mistakes people do, but much more dramatically. So if you show samples of people lying, telling the truth, humans will get like 62% of the truth correct, but only 47% of the lies. You put them together, you get 54%. Well, the AI will get 99% of the truth correct and 1% of the lies correct. And you put them together, you get 52%, right? So again, you have to kind of keep changing the prompts. And the only way AI outperforms the humans is you have to give AI the prompt that, hey, in this sample, about half of these examples are true, half are false. But in the real world, you don't know what that sample is, right? So that suggests that's a problem with some of the utility. A couple other things. When humans are given, we just sent this paper off yesterday for publication, right? When you give people an AI report of the truth or lie judgment, people tend to be biased in the direction of the AI. And the more they have familiarity or that they think AI is pretty cool, the more biased it will be. So AI will push their judgment in that direction. By the way, right or wrong, it's not making them more accurate, it's just they're following the AI. They trust the AI systems. There's this theory out there, it's called machine heuristic theory. And we as humans tend to trust machines more because we believe machines are unbiased. Humans can be biased, machines aren't. And AI seems to be falling in that category, particularly for younger people. They tend to see it as less biased. But again, given it's building on everything out there, that involves a lot of bias, okay? But the other thing is the AI stuff is actually trusted more when AI gives an example or provides an explanation. So there's a study where they gave some symptoms, AI made the diagnosis, but people trusted that diagnosis if AI said, because of this, and gave a reason for it, right? So that's another sort of human element that's going to be important here. Abdul, next one. And so take you over to some of the scarier parts about it. So a recent study had people use AI to write an essay or to cut and paste off the web or to use their own. and then is testing the extent to which AI might help you. In the old days, when people would cheat with the 3x5 cards and tiny notes, and they hide them up their sleeves, sometimes teachers would say, well, they're writing, at least they're learning something because they're writing it down. And it turns out that's true. But when you use the AI system to write the essay for you, and then when you're asked questions about the essay that you just wrote, either through AI or whatever, the 100% here is the error rate. So the people who used AI get 0 questions correct. The people who cut and pasted got 83% correct. So 0% versus 83, and those who did it old school got about 89% correct of those questions. So they're not really learning anything as a function of that. Can you go back that just for a second? On that. And this becomes a problem as we go along the way. So if you're using AI, particularly with kids, you're not developing basically the synapses in your brain. All right? It's like trying to build muscles by watching videos of guys lifting weights. Okay? It's just not going to work. You got to exercise it. I've been saying you get like a souffle brain, right? It's just like not going to work. So this is going to suggest in terms of some policy things. In fact, we talked to some of Chuck Schumer's people, who's the minority leader in the Senate. And one of the issues that came up is about using AI. And one of the lines is AI making an irrevocable decision or not? This is where the regulation has to come in. If using AI to, shoot down incoming missiles or something like that, without a human involved in the loop, who knows? There is an issue with technology in general, too. When you're implementing technology to help humans, people who understand the technology are good at using it as an adjunct to help their decision. But those who, as you devolve it, and we saw this in the airplane, as we move technology to the frontline people in the airport, they use the technology as a substitute for their judgment, not as an adjunct. But the people who understood it all used it as the adjunct. So as you employ AI, this becomes an issue to think down the line, Abdul. Now, there are some cautionary tales here. A lot of things are labeled as AI when they're not. There are some things that are AI that aren't labeled as such. But one of the problems with AI is because AI tends to be nice. And so people believe it. And there's a classic study on what we call the Barnum Personality Inventory. Everybody does a personality test, and then they get their own unique individual feedback. And everyone, how accurate does it capture you? And people give it a 5 out of 5. And then you get someone in the class, well, does anyone want to read their personality? And finally someone says yes, and he reads it, and they realize they all got the exact same personality description. But as long as it's positive and vaguely positive, people believe it. If you change it so it's slightly negative, then this is kind of crap. Right? They start to become more skeptical of it. And a lot of the AI stuff is conducive and people like it because it tends to be generally positive. It tends to respond back to people that way. So it's kind of doing like this Barnum personality stuff. And of course, again, it can, because it's nice and has some credibility to a lot of people, often some crap comes out. We've heard stories of AI, chat things, helping people commit suicide or things along those lines. Anyway, we'll skip the next one, go to the next slide here. By the way, there are some good things that can happen on it. Turns out, as mentioned, kids with the autism spectrum. So my colleague Ifoma is doing a study with these tiny little cube robots. And they have the little circles. That's like the eyes and stuff. And it turns out particularly kids on the autism spectrum like this. And what the thing does, it gives feedback. So if you pet it, it smiles. But if you shake it, it makes an anger face. Very simple anger face. All right? And they sort of actually begin to learn some empathic skills by interacting with this robot. Again, this tiny cube, you can see the size of it in relation to her hands over here on this, right? We talked about narrowing the haystack, some other positive use of this. And as I mentioned in some of the previous stuff, AI is helping us see things that we couldn't ordinarily see, like the dynamics and the flows of movements could be really helpful. Now, how do we use this? What's the most ethical way to use this stuff? We're not exactly sure. We have this AI in society in our university in the state of New York kicked in $40 million to help make this happen on this. And a lot of it is going to be like, we have classes on public speaking. We have classes on writing. We need classes on how to use AI in a proper way. Like, for example, I had a student who took my notes, made a multiple choice test to test herself for the quiz. That's a great use of AI, right? She used ChatGPT or something for that, right? That's great. That's not, taking away the burden of her applying her own brain power, exercising her own synapses along the way. But But it's funny how this stuff had been envisioned. There's this, you can see on YouTube, this ad from 1987 that Apple does. And they envisioned, though, that you would have like a guy, and it's a little guy in a window. He's like a secretary who tells you, well, you've got meetings today here and here, and you have to return a phone call to Professor so-and-so. And then the professor says, hey, can you tell me last year, give me 5 papers last year that were published on the rainforest and give me a quick summary. And that was 1987. So it's really interesting to see how this stuff goes. Anyway, Abdul, next one. And then to finish up here, the last one, right? Should we embody emotions in these systems? Should we? We can, but there's always a problem. One of my favorite quotes from Oscar Wilde was, the advantage of the emotions is that they lead us astray. They can be for good or for evil. So we have to be careful on that. And again, because the general niceness of AI and how people respond to that, right? So that can be an issue along the way. And then we can ask ourselves about what we could do with it versus what we should do with it. And those are separate questions to deal with. Do we use it as an adjunct for our decision making in certain elements? Sure. But are there times we can use it as a substitute for our decision making? And where are the parameters there as far as these things go? The other thing that's interesting is often as technology gets used in society, the technological becomes the psychological, right? So you look at houses in Buffalo built before 1910, they all have these front rooms because back then, almost all your visitors were unannounced. So you had this sterile room to make it look like your house was well kept, right? To keep the strangers out of the back room. Well, then you move to the suburbs, telephones exist, so people call. So you know when people are coming, right? So the design follows. How we use cell phones. Remember in the early days, people chatting in meetings like this. That doesn't happen anymore. We learn social media, what it does to us. We do know kids who spend more time on social media are worse at reading emotions and interacting with people. So, these things tend to happen. But the interesting thing about AI is, in this case, the psychological or the technological is the psychological. And that's a different thing. That's something new we have to still wrestle with. Now, can this help us free up our brain for more complex activities? Yeah. It turns out creativity needs time. You can't say, give me 5 ideas and do it in the next hour. They come to us at irregular times. So maybe that's something to do it. But anyway, ultimately, it may be helping us on this. And what I like is that, because it's, again, helping us discover stuff, understanding stuff, and understanding how people interact with us, and therefore helping us, get to some of that art that is underneath the science here. So anyway, thank you. My son works for M&T.
There might be a couple of questions.
When you were showing the picture of children, there was just the very tiniest bit of uncanny valley effect of it. Didn't quite look right, unlike an adult smile on a child or something. Where else does that show up, and how do and where does that get used in what you do? Yeah,
the movement, right? So if you're actually doing a dynamic movement. There's this great documentary called They Shall Not Grow Old by Peter Jackson, the guy who did all the Lord of the Rings stuff. And he found the World War I footage where, it's all kind of choppy. And they had to impute frames in there to get the movement to be natural. And they asked him, well, how did you figure it out? He goes, you just know it when you got it. All right, that's the science part of that. And I think we're going to see the same thing here. So my student Giuliani is creating, hopefully today, some sample using those new adjusted prompts to maybe get those AI, just to make sure we're totally out of the valley, so to speak. So it looks much more realistic, like the shot of the kid with the purple shirt that we show. So, and again, I think, given I've spent, I don't know how many thousands of hours looking at faces, I think we say, all right, we got it. Or we'll say, crap, we got to try something else.
We got one more question.
Yeah, my question is, how do you see information overload impacting people as well? For example, I'm really into AI. I've been a nerd since I was 16. I'm programming nonstop with it. I can't get enough done, but I find my brain is almost like I have smoke coming out of my ears. Yeah. I'm overwhelmed with information. How does that impact people?
Yeah, that's a huge problem. So one of the projects we're working in, so I'm friends with a guy who was a former head of the behavioral science unit at FBI. And we're actually looking at creating some AI systems, maybe put in body cameras for police officers to detect when someone might be violent based on some of these behaviors. But the problem we have with some of this stuff is, as you said, you get overwhelmed with it because they're looking at the hands, so you can't distract their eyes. So maybe something on the wrist to buzz to say, okay, be extra cautious. But what often happens when you feel the buzz, your eyes instantly go there, right? So I'm driving my little Subaru. If there's an object that goes beep, 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 and I don't look at the road, I look down at my dashboard. Why is that beeping? So you have to now retrain yourself to cut this out. Some of it is with training and practice, like we saw this with the airport on some of the behavioral stuff. Once you kind of turn it into what we call procedural memory, that frees up additional brain space to process. But actually, yeah, exactly figuring out how much. And sometimes what it means is you can't give people everything the system can do because it overwhelms. Can we find the top 2 or 3? Like, for example, there's a lot of behavioral things we look for bad guys in the airport. The original list was 37. And we said, can we get it down? Because the human +7 ± 2, short-term memory. So can we get it down to something like that, between 5 and 7 most important things? And that will help us better and enable people to do it and be able to function at the same time. So figuring out which parts of that to toss is also another question we're going to have to wrestle with, because that is a big issue.
Everybody, let's Mark, a big thank you.